Good afternoon. Welcome to the session on network monitoring. I am Ajay Gumadi. I also have my co-presenter here, Karthik Ananthakrishnan, who will join us later in the session. On Tuesday, our CVP launched a whole set of products, a whole set of networking products. Just give me where is the clicker? Yeah, sorry. Over the course of the week, we have given deep dives across various aspects of networking. So we have covered some of the connectivity related offerings. We have covered the application security related offerings as well as application delivery. In this session, we will cover the monitoring related pillar. So the offerings that we have that will help you debug, that will help you keep tabs on your network in the cloud and help you monitor networking related issues. While looking at the network monitoring itself, one of the big challenges with network monitoring is not the network itself, especially in the cloud. If you look at the concerns that people have about the cloud, if you have concerns about the on-premises network, it's one of availability. Availability is not as much of a problem on the cloud network. Redundancy on the cloud network is usually also much better than the typical on-premises network. The issue is one of visibility. On the cloud network, we do not have the relevant tools that give us visibility into what's going on. The cloud network appears to us as a big black box. We have, on the on-premises world, this is a solved problem with management vendors who have been in this business for the better part of 2 decades. And these people have provided a number of solutions across the entire gamut of network management. Now, the same management tools could be, you could argue, could be used on the cloud, but the reality is they don't work. These tools have not been updated for cloud readiness. They are not SDN aware. So the management or the management reach of many of these stops at the cloud perimeter. Fortunately for us, for Azure users and cloud users, the cloud vendors themselves have been providing cloud monitoring solutions. And how have we been doing it? We have been monitoring clouds for a long time. Even much before Azure, we have had properties such as our search engines, Hotmail, Windows Update, etc., and more recently Office and Azure, etc. So we have built tools that give us a higher degree of visibility. And in discussing these, I will cover most of the capabilities of these tools. In discussing these tools, I will draw parallels between what we do on premises and what the cloud set of tools can do. On the on-premises side, when you have an issue, you primarily start off with looking at your existing network monitoring solutions. There are a number of these. You could probably take an open source solution as an example, an MRTG or a Cactus. You look at them. These tools routinely draw information from various points on network, typically routers and switches, and present them by way of charts, etc., charts, gauges, dials, etc. Now, should you find any sustained abnormality in these graphs or presentations, that's when you look at the diagnostic logs. We call this overall phase as the review phase, wherein you are just looking for, is there a problem? Is there a deviation from the existing network? Azure networking provides a number of tools in the review phase itself, and I will cover some of these in the next few minutes. The next phase is the troubleshooting phase. This is where you are going to check if, so you have discovered that there is something potentially wrong in the network. Now the next step is to ascertain that yes, something is wrong and what is the exact problem, and finally remediate it. This is what we call the troubleshooting phase. On the on-premises network, you primarily start off with ping and traceroute. You use ping to test the availability of the other endpoint, of the remote endpoint, and then subsequently, if you find an issue with performance, that's when you use traceroute to either determine the path or determine the segment on the path where there is a problem. This is where we have a number of tools that cover various aspects of the network. So we have the connection monitor, VPN troubleshoot, etc., and I'll go over many of these. Now, ideally, on the cloud network, given that it's dynamic, you don't want to spend person hours on debugging, on reviewing a lot of the data and troubleshooting on a continuous basis. That's where the role of monitoring solutions comes in. So you have solutions like Network Watcher and sub-solutions within Network Watcher like Network Performance Monitor, which will do end-to-end monitoring for you and report only when they detect an issue. They will be specific about the nature of the issue, so you can go in and fix the problem. Once you have your monitoring in place, the monitoring solution itself is accepted, the procedures are worked out, agreed upon by people, and it's part of your workflow. The next step is to optimize your overall environment. That's where solutions like traffic analytics and again NPM come into a picture. This is where you move your network to the next level, where you're either optimizing it for capacity, you're optimizing it for performance, for efficiency, etc. And finally, we do realize that data exists in other silos. You may be capturing health, performance-related data from other parts of your infrastructure, be it storage, be it applications, etc., and you would ideally want to correlate data across all of these silos. So our solutions, the Network Watcher portfolio of solutions, allow you to export the data, allow you to consume the data in across other solutions. So moving on to the first solution in the review category, which is Azure Monitor. In the pre-cloud world, on our Windows boxes, on our Windows clients and servers, we were used to event logs. That's where the operating system put its health information. Applications also gradually added their health information onto it. And correspondingly, on the Linux and the network world, we had syslogs information. Now, in the Azure or in the Azure cloud, all of the infrastructure and some of the applications put all of their operational signals and health signals into Azure Monitor. This is a snapshot of some of the key networking functions that we have in the cloud and the metrics that they put out in Azure Monitor. So typically, the most common metrics that you need to see if things are fine or there are any abnormalities or deviations that you should, that's the metrics explorer, that's the metrics part. So you have the typical metrics such as bytes in, bytes out, failed requests, number of successful requests, etc. Resource exhaustion issues, etc. If you need to drill further, you can also access the logs, the diagnostic logs from each of these. Think of Azure Monitor as the event log or the event viewer for the cloud. So you can create your own, you can select the metrics that you want to track and create dashboards out of these. Should you choose to, if you are interested in offline processing of any of this data, you can click on the download link and access the data in the JSON format. The data itself, given the large volume of data, you can it has access to filters, so you can slice the data. You can also generate alerts. The Azure Monitor is tightly integrated with Azure Alerts, so you can generate alerts. The typical flow of alerts are you can either consume them as emails or SMSs, or if you have orchestration systems in place, you can use logic apps or webhooks to consume this data. The data itself is generated every minute by the networking system and is retained for 3 months. Now, you have, through Azure Monitor, you have looked at the various signals and you have detected that there is a networking issue. The next step is to determine, the next step is to double down and check what the issue is. That's where Network Watcher comes in. Network Watcher is a cloud-aware network monitoring solution, network monitoring suite of solutions. It has various sub-capabilities within it. So like the ping and the trace route that we discussed earlier, so you can do connectivity checks. You can troubleshoot configuration issues, networking issues, routing issues, or firewall-related issues that may be hindering connectivity. You can also do packet captures, and we'll go through some of these in the next few minutes. You can capture the transactions on your network, or you can do monitorings through network performance monitor and traffic analytics. The easiest way to get to Network Watcher is to search for Network Watcher in the search portal, and you will see the whole slew of capabilities available within Network Watcher. Now, looking at the first solution, the connectivity monitor, think of this as the equivalent of ping and traceroute written for the cloud. It is Azure topology aware, it is logical topology aware, which means it can detect the various points, the various hops in the network, not the physical routers and switches on the network, but the Azure topology as we as a customer see it. It can detect configuration related issues, NSG issues that may be blocking connectivity. So in this particular case, I have an Azure VM on my left side that is trying to connect to an on-premises VM on the right, on the extreme right. Connection monitor has detected that there are 3 different hops. 2 of those hops are in Azure, and 1 is the remote router on premises. It has done the necessary diagnostics and detected that the packets are unable to get past the first gateway because there is a NSG rule in the VNet which is blocking all outgoing traffic. Let's take another example wherein we have a multi-tier application that is not functional. Again, a 3-tier application. Again, running connection monitor here informs us that the front end is the front end, which is the first green nick that you see, is able to connect to the middle tier or the application tier. But the middle tier is not able to connect to the last tier, the rightmost neck, which is hosting the database. Here in this case, the database is again hosted on a VM, and the firewall on the VM is blocking incoming traffic. You can schedule connection monitor tests on a routine basis. You can set it in multiples of a minute. You can also set alerts on round trip time and packet drops. Should you choose to integrate this data, again, as with all for network monitoring solutions, you can integrate it with logic apps. Now, connection monitoring itself works from, you can run this test from any VM or any application gateway in Azure to any destination. A destination here being a combination of an IP address and a port. We also have diagnostics and health information for other capabilities that were announced on Tuesday. So we have diagnostics and health information for virtual WAN, for VPN gateway, etc. When you use VPN to connect to external networks, the health of the connection itself is a function of 2 variables. One is the health of the gateway, and the second one is the gateway connection itself. Running VPN diagnostics available from within your Network Watcher portal will check both the gateway itself and the health and the gateway connection. You can access, should you need, you can access the gateway logs also. We check for about 20 different issues. Many of the common issues that we find are issues such as the remote gateway may be improperly configured. There may be a key mismatch. The WIP may not be functional, etc. These are found. You can also access the diagnostic logs in this case. There may be situations wherein the network itself is functional. So there are applications on the network that are able to talk and perform the necessary interactions, but a specific application may be having issues, probably due to the way it interacts with the network. That's when you could use packet capture. In the case of packet capture, we generate the packet capture in the widely used .cap format. So there are a lot of tools, open source tools and commercial tools that analyze this and provide reporting on this. The packet capture is supported on both the operating systems, Linux and Windows. You can store the data either into a blob file or into a storage blob or into a file on the local VM. Given the large volume of data that can be generated with the packet capture over time, we have the necessary filters that you can use while generating the data. So you can, for example, limit the packet capture to a certain duration. You can also limit the duration, the packet capture to certain headers, just in case you are interested in the headers. You can also limit the packet capture to apply only when a specific IP on the local side or on the remote side is involved. Now, there will be instances, especially in organizations that act or operate in highly regulated industries, wherein they have to keep a track of all of the interactions on the network. So in this particular case, you can turn on NSG flow logs. A flow log here is a transaction, is the record of a transaction between a source and a destination. A flow log contains the source, the destination it was trying to reach, the time the transaction was attempted, and whether the transaction went through or was blocked because of an NSG. Now, many of the organizations across healthcare, across insurance, and many other regulated industrial verticals use flow logs on a regular basis to capture and keep a record of the state of their network for audit purposes. We generate the flow logs at a very low latency. Usually the data is available in the storage blob in under 5 minutes. A recent enhancement to NSG flow logs allows us to capture the flow logs across all of your subscriptions. Given that these organizations have multiple subscriptions, often catering to various departments, you can capture all of the subscriptions in all of the flow logs from across your subscriptions into a single subscription. There are a number of tools, both from third-party partners as well as from Microsoft, for analyzing the flow log data. Traffic Analytics is a solution from Microsoft that solves the same problem. Traffic Analytics primarily looks at the flow log data, and one of the biggest issues with the networking in the cloud is lack of visibility, and Traffic Analytics attempts to solve that. When it comes to visibility, so here you have the dashboard, the global map, and it gives you an overview of how you are using the cloud, the number of regions that are active, the number of regions you have deployed your workloads into, the number of VNets, what is the state of, do you have malicious traffic on your network? With regards to visibility, we can also tell you which regions are talking to which other regions. Are there VNets that are basically inactive? What traffic or what applications are running on your network? It's possible that during the design phase, your network architect had designated a particular VNet primarily for front-end servers, and over a period of time, someone has installed a database server on the VNet. How would you detect it without looking at the VM itself? It would be a fairly tedious task to look into each of the VMs and see what was the workload involved. You run Traffic Analytics, it's basically agentless. You would be able to detect the type of workload that was running in. You would be able to audit your network here. You can also discuss, should your network be overloaded? You can also detect who the top talkers are. You can also detect the protocols in use, the conversation pairs that are active on the network. From a security standpoint, Traffic Analytics can find which of your VMs or which of your subnets are talking to known malicious sources. So we look at the flow logs, combine it with other security feeds that we have, that we use as part of the digital crimes unit, and we can give you security related insights. It's possible that you have some VMs that are really back-end VMs that are attempting communication to the outside. We can detect that. This is information that you can use to tighten or better design your NSGs. The third use case for Traffic Analytics is optimization. In this particular case, you'll see that we have deployed our workloads. One of our services has deployed our workloads in the East US region, wherein the bulk of the users are coming in from either Europe or Asia region. Now, that should be an obvious sign that your workload is better off being in the Asia region. The performance for the users is better because the latency is going to be significantly reduced when the servers are closer to the users. A second optimization, we can also detect which VNets are inactive. Basically, that means you have VNets with VMs, but those VMs are not generating any traffic. Possibly they're inactive. You can reduce, shut them down, and reduce costs. We have a solution that monitors network, end-to-end monitoring of networks, network performance monitor. It monitors connectivity between any 2 points on a network. The 2 points may be 2 subnets, 2 branches, a branch and a data center, or a branch and a cloud, or any combinations of these. So here, network performance monitor is monitoring connectivity to Exchange Online. So we can also monitor connectivity to third-party services, web services, CRM services, etc. It has detected all of the paths available between the source and a destination. For each of the path, it has detected all of the hops and the performance of each hop or the latency across each hop. Now, quite often we run into, whenever there is a service outage, we run into an issue whether it's a, the question that usually arises and leads to a lot of back and forth is whether it's a networking issue or an application issue. Network performance monitor can help you disambiguate here. So the top line, the purple line that you see, the line with a lot of spikes, that's the application response time. And the yellow line below, the orange line below is the network latency time, is the network latency graph. As you can see, the network latency is fairly constant, whereas the application latency is, the application response time is spiky. So in this particular case, the network is not the problem. It's an application issue. The performance degradation is due to an application. Now contrast this with this particular chart, wherein you see that whenever there has been a spike in network performance, network latency, there has always been a spike, corresponding spike in application response times. Network performance monitor can also monitor express route circuits. We monitor both the primary and secondary circuits available, and we can give you the loss and latency across this circuit. We can also detect other conditions such as the primary may be up, but the secondary is down. So it looks like the express route circuit itself is functional, but you're just waiting for the primary to fail before you lose connectivity. Other conditions such as, yes, the express route circuit is fine, but routes are misconfigured and traffic is not flowing through express route. So you're basically paying for a service that you are not utilizing. The other condition that can be detected here. We can detect the capacity utilization, that is the ER bandwidth utilized or used by any particular VNet in the case of private peering. We can monitor both private peering as well as Microsoft peering. A recent enhancement and that we have released or launched at Ignite is the ability to use one instance of NPM to monitor express route circuits across all of your subscriptions. With that, I would like to invite Karthik to continue the session on Vita.
Hi. So Ajay talked a lot about diagnostics and troubleshooting, which we natively support in Azure. So what I want to talk about is a new capability that we are launching in Azure within networking. This is to bring a completely new ecosystem into Azure. And the scenario is basically you, in your on-premises data center networks, you are used to solutions that require deep packet inspections, continuous monitoring of networks. You have your IDS and IDP solutions, and you want to be able to use those capabilities in Azure, and you want to look for some native capabilities in Azure for that. So we are launching this new capability, and I want to talk a little bit about that. So let me take a step back. I want to kind of set the context on where we are coming from with respect to thinking about the solution. So if I were to start with a traditional on-premises network, you have your infrastructure, the physical network, and the connectivity between the devices and stuff like that. So if you were to now get traffic from this and you want to do analytics and performance management and other scenarios that you want to manage with this, today what you do is basically you go and attach a tap. You place a tap at different points in your network. This tap is basically something that doesn't interrupt with the production traffic. You are able to make a copy of the packet, and you are able to send it to your network packet brokers. So the network packet brokers are typically hardware appliances that you deploy in your data centers, and you acquire the traffic from that. So what you then do is basically you have an entire ecosystem of different types of operations, application operations, network operations, security operations, and forensics basically. These are scenarios where you are basically taking a deep copy of the entire payload that is going through your network. You are streaming them to these packet brokers, and the packet brokers are able to send this traffic to these tools. The tools require the metadata from the packet brokers, so you are able to kind of manage this type of a setup in your on-premises data center. Now, when this entire traffic moves to the cloud and you are lifting and shifting these workloads and it moves to the cloud, the question that a lot of customers are asking us is, how do I get complete visibility for my workloads in the cloud? Troubleshooting and diagnostics and packet capture is one scenario, basically where you are able to take the data and solve some of the problems. But if you have forensics, if you want to do roll the tape of scenarios, and if you want to find out if there is any performance issues between your hybrid deployments between on-prem and the cloud and stuff like that, and you're using some tools in the on-premises and you want to use the same thing, bring those tools into the cloud. So customers have been looking for a solution like this. So just about a year back, we looked at this problem. We have been looking at it quite closely. So we have at this point in production, we have a couple of solutions available in the marketplace. These solutions are agent-based. So in this scenario, I highlighted a solution that Gigamon has in our marketplace. Their solution is called GigaSecure. There are other solutions that ExtraHop and others have as well. These solutions use agents. The agents are used to acquire the traffic from your virtual machines and your virtual networks. And they stream the packet to these V-series, which are basically network virtual appliances, which can aggregate the traffic from multiple virtual machines. And then you are able to then kind of stream it to multiple different tools, basically. So this solution is available in the marketplace. It works efficiently, and everything is fine. But this is agent-based. Agent-based solutions has a lot of problems when you think about security scenarios. If you are thinking about feeding these solutions into some type of a security analytics tools, you have a vulnerability and a threat detection type of problems with installing agents on your VMs, basically. There is also coverage gaps that you cannot solve with the agent-based solutions. It's not able to acquire traffic from every different deployment that you're doing, workloads that you're running in Azure. It also has performance implications. And then if you already have an operating workload in the cloud and you want to now use an agent-based solutions, to be able to retrofit an agent-based solution to work with your existing workloads is a challenge, basically. So it also causes a lot of friction between security operations in your organizations, network operations, and DevOps, because DevOps manage the workload, and security ops now need an access into your virtual machines to be able to run the agents and also to be able to maintain and update the agents and stuff like that. So all of this kind of in the context of continuous visibility for traffic in the cloud, kind of it came together, and we have been thinking about this problem and how to solve the problem and how to bring this ecosystem back to Azure and provide solutions to customers. So today we are happy to announce a platform native solution to be able to acquire traffic from the public cloud without using agents. So there is nothing that you need to install in the, on your virtual machines. It's basically just like how you do network security groups, application security groups, and stuff like that. This is a platform capability where using our Azure Resource Manager APIs, you will be able to go and attach a tab on a VM, and any traffic going through that VM, you'll be able to stream it to a destination. So this is virtual network tab. So in this picture, I have virtual machines in a web tier subnet and an app tier subnet. We are attaching a tab configurations on these virtual machines. So all this traffic is continuously streamed to these packet brokers. So to that end, what we have done is basically we have worked with a handful of network virtual appliance partners, and we have brought them into the cloud, and they are working towards launching their solutions in the marketplace. Now, behind these packet brokers, you have all these tools for application performance management, network performance management, and forensics and security. So we are building and growing ecosystem of these partners who are going to offer their solution into the cloud, basically. So again, yeah, agentless, continuous streaming, and enabling an ecosystem of partners who are going to offer their solution. And the other thing that I wanted to highlight is just like your traditional data center networks, if you had security operations who had the discretion of placing the tap devices wherever they wanted and be able to acquire the traffic and send it to the packet brokers and tools, we are able to do the same thing in Azure just by role-based access control and the fact that we expose these as resources for you to be able to kind of administrate policies on them. So you can achieve complete segmentation of a security ops role and a VM owner role, so that the security ops is able to enable or disable a tap within a monitoring boundary, and the VM owner will not be able to tamper with the tap. So yep, here is the ecosystem of partners. So starting from the bottom, we have the packet brokers. We have Big Switch, Gigamon, Ixia, and Nubeva. One of the things I wanted to highlight with the packet brokers is the way this ecosystem is moving is basically you don't have to kind of go and reactively go and configure a tap within a monitoring boundary. So some of these solutions are very creative. They go and snap a monitoring boundary. It could be a subscription, or it could be a set of resource groups within that, or it could be virtual networks within a region. You can go and kind of say that here is my monitoring boundary. I want to acquire the traffic. So what they will do is they talk to the virtual network tap APIs. They automatically attach a tap on the virtual machines, and they acquire the traffic, and they can stream it to their equivalent of a packet collector and then to the tools, basically. Then we also have NetScout and Flowmon, which are kind of providing application performance management and network performance management solutions. And in the security space, we have been able to build a good ecosystem of partners. We have ExtraHop, Fidelis, RSA NetWitness, and Vectra Cognito, basically. So these are very creative solutions which offer machine learning-based threat detection and other solutions. So with that, I want to show a cool demo. For this demo, I'm using ExtraHop RevealX. ExtraHop does a very good job at threat detection and analytics. So let me just show you my demo scenario, basically. So what I have here is basically, I have a couple of VMs in my application tier, and I have VMs in my database tier. So in this case, I'm going to mimic the VM in the application tier to be malicious. It is doing port scan on the VMs in the database tier. So the fact that there is a port scan happening, the entire traffic between the application tier VM and the database tier VM, I'm going to tab the traffic on the database tier VMs. So when I do that, all the traffic that is there going through the database tier VMs is now going to be streamed to the ExtraHop appliance. And you'll be able to see that in the ExtraHop appliance, I'm able to see an alert on all those database VMs that are now affected by that application VM sending port scan traffic. So let's switch to the demo. So what I've done to make it easy for me for the demo setup is I've already created a tap resource. This is basically, I'm using CLI at this point. Eventually, we'll have portal capabilities, and we have PowerShell, and we have all the tool support that is required. So what I have here is basically, I've created a virtual network taps resource, and I've specified that I want to send all the traffic to a particular network interface within a virtual network. You can configure this tab so that the source and the destination could be in the same virtual network, or could be in different peered virtual networks. So let me also, so just as the exact same setup with ExtraHop, I also have a setup where I want to show you actually how the packet looks and stuff like that. So I have a parallel setup where I'm going to run Wireshark on one of these VMs. You can think about this VM as one of the destinations where I'm going to send a mirrored traffic to, basically. So now let me add the tap. So all I'm doing is basically a complete remote administration. If you are using a packet broker, a Gigamon, or a Big Switch, or any other solutions, they're going to automatically do it for you. In this case, I'm using a CLI command to go and attach a tap to that particular VM. I don't have any agents. I'm just remotely going and calling an API, and it is now saying that any traffic going through that VM, ingress or egress, I want a copy of that. So let's switch to the Wireshark tool. And here, if you are seeing, these are the mirrored traffic that is coming into the Wireshark VM. So any traffic that is going through the production VM, we are making a copy of it without having any agents, and it is continuously streamed to this destination. So to make it more fun, let me switch to my application VM. So this is the VM. This is my malicious VM. I'm going to now initiate a port scan from here. It is going to do an intense TCP port scan across an IP range. Basically, the IP range is from 10.6.2.4 to 10.6.4.7. This is all the VMs on the database subnet that I'm going to do a port scan on, basically. So let's see what happens. So the port scan has started here. It is targeting the port scan on all of these VMs in the database tier from 10.6.2.4 to 4.7. So let me switch to the Wireshark and see and show you how this looks on the Wireshark side. So if you see here, I'm able to see all the traffic that is going from the app tier VM. I'm not tapping the app tier VM. It is just that the app tier VM is targeting all the VMs in the database subnet, and I'm able to see all the traffic mirrored to this Wireshark VM from where I'm able to see the dump. So the same setup, let me switch to the extra op appliance and show you how it looks. So in the extra op appliance, to kind of have this demo setup, what I've done is I have created a device group. Device group is basically all my VMs within my monitoring boundary. So, and this malicious app tier VM, which is at 10.6.1.4, is a VM that is initiating the traffic. So let me switch here and show you an activity map on how it looks. So this entire view that is created now for you is basically based on the mirrored traffic. The production traffic on the VMs are not impacted in any ways. So it is sending all this traffic to this extra op appliance. The extra op appliance is doing a deep packet inspection of the entire payload that is coming from the malicious VMs to this database tier VMs, and it is rendering this view for you. So now, with the perception that there is an attack, if I just, I have set up an alert on this for TCP sends, and I'm able to now see that all of these database VMs are now within the vicinity of an attack, basically. So let me just also zoom in on this particular so if I look at this malicious VM, and I look at the TCP packet sent out of this, there is a high rate of TCP sends sent out of this application tier VM. So that the extra op appliance is now able to get each of those packets, and it is able to do this kind of analysis on those packets. So there is also a layering on this where if I go into these appliances, they are also able to kind of give advanced information in terms of an actual threat that has happened during the time window, and it is able to report that this particular malicious app VM is the one that caused this attack, basically. So with that, let me just switch back to my slide deck. So now I showed an extra op appliance that is capable of doing this. I'm going to show you a small video of how NetScout is using virtual network tap, and they are able to kind of provide solutions to customers in the applications performance management and network performance management space.
Microsoft Azure VTAP with NetScout Application Assurance. NetScout translates the unstructured packet data, aka wire data, into key performance metrics or smart data to monitor the health of networks, applications, and their dependencies. The components of the solution comprise vStream, which generates the smart data and stores and indexes the wire data from Azure VTAP, and the Ingenious One platform, which receives the smart data and provides top-down workflows to triage, isolate, and solve complex issues in hybrid deployments. It offers intelligent analysis, baselining, alerting, reporting, dashboarding, and drilling down into issues it sees. This demo shows Ingenious One in action, monitoring a multi-tiered application in the Azure cloud. Here's the Ingenious One dashboard, with each tile illustrating high-level metrics of the application layers discovered from the traffic received from VTAP. The orders application, web, app, and database layers, HTTP, HTTPS, SSH, and of course DNS. We've highlighted these metrics on application failures, but of course there's many to choose from. From this we can see that both orders app layer and DNS have problems. Let's dig into the orders app layer by looking at the specialized services monitor. The top rows indicate key performance metrics, latency, requests, and failures for the client-server interactions of the VMs. If we focus in on the performance between App Server 1 from the Order Entry 1 server, we see application latency is high and generally much higher than other communications here. And looking at the performance variation over time, we see this is consistently degraded. We also see the error code distribution between these applications show 404 and 500 application errors. So 2 issues in this environment quickly discovered. To drill down on these issues, we can go to session analysis, and this is where Ingenious One leverages the clever indexing of vStream. and Genius One requests just the selected sessions. Here we show sessions metrics ranging from the URL being attempted, the consistently slow order search, as well as the errors with ladder diagram on order history with error 500 internal server error. And yes, from here we can quickly mine the packets stored in vStream. This shows the forensics with the exact detail of the responses and where the errors are from. You also see this is from VTAP by virtue of seeing the VXLAN encapsulation, but for this demonstration it's important to note that NetScout is analyzing the performance inside the encapsulation, and we see this as HTTP application traffic. In summary, this was a quick demonstration of Azure VTAP providing the wire data which is transformed to smart data by NetScout vStream technology, and in combination with and Genius One provides key insights to our application service performance and dependencies in the hybrid cloud.
So at this point we are previewing virtual network tap, and we are happy to receive some quotes from the customers who are trying this capability. It's very exciting to see that we are able to stoke an ecosystem of partners who are looking into offering solutions using the VTAP capabilities. So to that end, I want to roll a video of a solution that a partner is using with ExtraHub.
Flexibility, resiliency, and scalability are some of the key initiatives involved in us making the decision to move to public cloud. We decided to go with Azure versus other cloud providers due to the seamless integration with our on-premise infrastructure and being able to scale and flex into the cloud. We have an in-depth Microsoft stack here on our on-premise infrastructure. We use applications like System Center, OMS, and Hyper-V, which seamlessly integrate into the cloud space. So ExtraHop has actually played a key role in our on-premise infrastructure. Our initial partnership has been extremely successful in helping us, and we're very excited to actually be able to use them in the cloud space so that we can integrate with our on-premise and Azure space. The virtual network tap in Azure will actually help reduce the management overhead and total cost of ownership by not having to install agent-based clients on every single host that we deploy to our production cloud. It will also certainly help with the ease of deployment. It was actually a really good experience. ExtraHop provides the complete total solution.
Yep, so at this point we are in preview. So what we would like to do is basically for any customers who are interested in trying this capability, there's a lot of documentation on our website as well. If you could please send an email to this mailing list. What we want to be able to do is make sure that your onboarding experience is good and you have a very good experience. So we would like to match you with a partner with whom you'll have an end-to-end solution. So if you're interested in this capability, yep, we are at a preview, and we are going to try to quickly get this into a general available capability. So if you're a partner who is trying to provide a solution with VTAP, we have an email here. So you can email us and we'll evaluate on how to make you a partner. So here are all the announcements that we are making today in the monitoring session. Yep, that's it. We can meet for questions.